Hey, what's happening, guys? It's new multimeter time. And today we have the Holdpeak HP 770D, which was sent to us by our friends at Banggood for our consideration. So big thanks to the fellas and ladies at Banggood for sending this out. Now this meter is a 40,000 counts meter, which is very nice. And you can see we have, at this point, 4 digits after the decimal point, which makes it have a very, very nice resolution. Oops. And now it's even in focus, which is always better. So if we take a look at this and compare it to the size of some other meters, there it is compared to the 8008 and compared to this O1. It is a full-size meter. So we're looking at almost 20 millimeters by 8.5 or so. Full-size meter, very nice. Now, one of the features of this meter that you're going to notice here are these guards down here. And as we rotate the selector switch, you can see it switches the guards into different positions depending on what we're trying to read, and that works out really nice. You can't accidentally put them in the wrong space. If you have your probes in the amperage space and you try to read a high voltage, well, you're going to blow out your fuse, because that's basically a dead short. This meter is rated Cat 3, 1000 volts. But we'll take a look inside and see how it compares. The meter comes with a K-type thermocouple on a long probe. Nice case with an instruction manual and your standard set of crappy leads, which I will not be using because I never use them. I use a nice set of ProbeMaster gold-plated probes for every multimeter I test. That way every multimeter is tested with the same set of probes, and we're only testing the multimeter, not the probes that it comes with. I know some of you don't like that, but that's the way it is. Alright, let's start by testing some voltages with my voltage standard. And one thing a little odd here is the common terminal is on the outside. I'm not used to that. Every other meter I have, the voltage terminal is on the outside and the common is in the middle. So it's auto ranging, and we will put it in voltage mode. I have my voltage standard here. It's been warming up for a while, and it is on 2.5 volts. So let's see what we get. 2.5075. Not bad at all. Next we'll go to 5 volts. 5.012. 7.5 is next. Get my probes in the right polarity. 7.499, and finally 10 volts. 10.005. So relatively close. Let's try a little experiment. Alright, I got the fluke out, which is my most precise meter, and we will hook these up in parallel. We use some nice 4mm banana cables, hook them up to a power supply. Okay, I've got them hooked up in parallel here. So let's see how closely they track. We'll start off with half a volt. We get 0.5149, 0.5153. It's pretty close. At these low voltages, there's 1 volt. We get 1.008 on the fluke, 1.009 there. Go up to, say, 5 volts. 5.0129 on the fluke, 5.012 on the Holdpeak. Take it up to 10 volts. And it's tracking pretty close there. Go up to 20 volts. 20.009, 20.009 right on. And the maximum voltage for my little power supply, 23.07, 23.07, 23.07. So for DC voltages that you're going to play with at home, I'd say this guy is right on the money. For our next test, we're going to do resistance. And for that, we're going to use these little test leads that I've made up. Very nice gold-plated banana plugs, silicone 16-gauge wire. And just so that you can see here, there's virtually no resistance in those cables whatsoever. So what do you say? Do we start low or do we start high? Let's start low. 2.2 ohms. Auto ranging 2.3, 2.27, 5, 4, 3, 2, 3. I'd say we're right on. Now, of course, the speed isn't super fantastic, but I'd rather have accuracy than speed. All right, next up, 1K. And again, we get an initial reading relatively quickly, and then it settles down. You also see we have a very nice bar graph display here. 10K is next. This generally reads about 10.04, I think. Yeah, 10.044. And then we'll go with 1 meg, which reads about 998. .996. I'd call that close enough and definitely within spec. Let's take a look at some diodes and capacitors. Alright, so we've got it right now in resistance mode. Here's diode mode. And we'll check a standard silicone diode here. We should see between 0.5 and 0.6, 0.53. This is a super fast diode. Should also be about 0.5, 0.46. And a Zener should be somewhere around, I'm sorry, not a Zener, a Schottky. Should be somewhere around 0.2. If I can get a connection on it. There we go, 0.1997. Alright, now I have some LEDs here. First one is red, I believe. Purple. You see it lighting up there? So it lights up the diode, but it doesn't show a value. Next is green, which is very slightly lit, 1.84. And then we have a blue, which Yeah, barely lights it, but no reading. Then we have a big, this is a 100 microfarad capacitor, so we'll go to capacitance. These take a little while to charge up. 0.94, pretty close. You have a couple of small ones. That should be 0.5, but close enough. And this should be around 99. 93. Okay. Not too bad. Alright, let's check continuity mode here. Okay, that is not terribly impressive. That's kind of disappointing. Okay, well, nothing can be perfect, right? Right. All right, let's go to voltage again. And this time we'll go AC voltage and see what flavor AEP has for us this evening. Somewhere around 125 volts, I would assume. 124.3. Let's check frequency. Right about 60 hertz. Looking pretty good. Everything so far seems to be working out okay. I have no complaints so far other than the continuity mode does not latch very well. There's one feature that I find very cool in this I want to share with you. If you can see that there, auto backlight. Watch what happens when I turn the lights out. Well, I guess I should turn them all out, huh? Hold on, here we go. And I should probably turn that off too. Kaboom! Auto backlight. How cool is that? I've never had a meter that had that before. Turn the lights on and it goes back off. I like that. Next up, let's take a look at current readings. We're going to go with some low current readings, milliamps here. I'll hook up the leads and we can see we're set for 1 milliamp. 0.999. Oh, 1. Not bad. Let's take her up. 2 milliamps. 3 milliamps. 4 milliamps. Go up to 10 milliamp. Very nice. You can see the bar graph there going right along with it. 20 milliamps. And 20 milliamps is as high as we can go here. So, not too shabby. You can see we also have a microamp setting. And we got the crazy ass transistor tester that all these Chinese meter makers feel they need to put on here. I personally don't. And we also have a non-contact voltage. So you can see we are definitely reading some voltage. It has a nice bar graph display. So I say that's enough playing around with it. Why don't we see what it has to offer on the inside? Alright, I took its condom off. I guess I should probably take out the battery too. That little guy out the hole there. Come on. There we go. Okay. So now we can see the guts. Alright, first of all, we have a 500 milliamp, 500 volt HRC fuse for the low current. A 20 amp, 500 volt fuse for the high current. There's our shunt right there. And I don't see jack all for protection. So this is definitely going to be a low voltage meter only. I would not recommend this for household AC voltages or higher, because there is no protection whatsoever here. We have a voltage divider there. I mean, that's it. There are switches coming in. We got a couple ICs there. It looks like the LCD is driven by an HY11P14. Let me see if I can make out this other one. Wow, that is really small. Hold on a second. Can you guys make that out? HY231334. I'll have to look at it when I edit this, because I can't tell what it is. There's a buzzer. This thing is pretty simple. There's our non-contact voltage measuring. There's our transistor testing. This is a pretty bare board. Oh, pardon me. There is just a 1 positive temperature coefficient thermistor there for protection. Still, yeah. Yeah, definitely keeping this for low voltage apps only. Assembly here, you do see there is a nice lip going all the way around there. That'll definitely help to keep the exploding parts in if you have a bad day at the office. But if you keep this to low voltage like I recommended to you, I don't think you'd really have much of an issue. Oh yes. Ah yes. It would help muchly if I put it on in the proper direction, right? Right. Okay, you don't need to watch this. It is nicely constructed. Two screws to get out the battery or the fuses, so that's not too terrible at all. You'd also see we have a magnetic connector there for hanging it from a strap, but they did not provide the strap in the package, so there's that. Now, price wise, this thing is a little bit pricey. It's around $80 from Banggood. Is it worth $80? I can't tell. I just got it. Would I recommend this meter? From what I see so far, yes, I think I probably would. Considering, you know, you keep it for what it is. You know, if you're working in a power plant as an electrician, this is not the meter for you. Working around your house, doing some electronics, maybe troubleshooting your stereo, yeah, probably alright. Unless you have an old tube stereo. There's some high voltages in there, you definitely shouldn't be getting in there unless you know what you're doing. Anyway, I will put a link to this down below. Thank you guys for watching. Big thanks to Banggood for sending it. You know, I do love meters. In case you couldn't tell. That's it. I'm out. Peace.